आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Okay, so hello everybody. Now this question over here says that what is meant by hybridization? Further it is saying that this particular compound contains sp or sp2 hybridized carbon atoms. So we have to find the hybridization of the carbons available over here and then tell what is a planar molecule. So we basically have three parts in this question. So let us begin with the first one, which says what is meant by hybridization. So let me write hybridization. So hybridization is an idea. It's not something that is there for sure. It is an idea that atomic orbitals fuse to form newly hybridized orbitals, and which in turn influence molecular geometry and bonding properties. So basically, it is defining the bonding properties of an atom. So basically, hybridization, let me write, it is an idea for defining the bonding properties and the molecular geometry. So let me write molecular geometry and the bonding properties. So this is what hybridization is. Now let us move on to the second part, which is saying us to find the hybridization of this particular compound, the carbons in this particular compound. So let me draw that compound first of all. So it is C H H double bond, C double bond, C H and H. So this is the compound that has been given to us. So now we know that hybridization is calculated by the sigma bonds itself, because only sigma bonds participate in hybridization and pi bonds don't participate. And for the carbon, we know that since carbon valency is 4, so it can only form 4 bonds with another compound or another atom. So therefore, let me write, if all the 4 bonds are sigma bonds, so that means 4 sigma bonds, for that the hybridization is sp3. Basically, first sigma bond is contributing for the s orbital and the other 3 for the p, so sp3. And let's say if there are 3 sigma bonds and one pi bond, then the hybridization will be sp2. The first sigma bond will contribute for the s orbital and the other 2 for the sp2, and since pi bond doesn't contribute, so only sp2. And if let's say we have 2 sigma bonds, then this hybridization comes out to be sp with the same logic. Now in this particular question, we have to just look at the sigma bonds. So the bonds that I'm highlighting are sigma. So we know that the first bond that is formed between carbon and carbon is always sigma. So therefore this bond is sigma. This bond is also sigma, and this is also sigma. This one over here, the above one, is pi, because the second bond the second bond that is formed between carbon and carbon is a pi bond. So from here we can see that this particular carbon has 3 sigma bonds. Therefore its hybridization will be sp2. Now coming to the second carbon atom, over here we can see it has 1 and 2 sigma bonds. Therefore its hybridization will be sp. And for the third carbon, 1, 2 and 3. So therefore its hybridization is sp2. Now these are the hybridization of this particular compound. So from here we can see that this compound contains sp or sp2 hybridized carbon. This is asking. So it contains both of these carbons, both of these hybridized carbons. So with this we have completed the second part as well. And our third part is what is a planar molecule. So we know that planar compounds or planar molecules are those molecules which lie in a single plane. So let me write planar molecule which lie in a single plane. So lie in a single plane. So we know that when a compound has hybridization, when basically carbon compound has hybridization sp and sp2, then it is planar. How? Because we know that the shape of sp is linear and sp2 is trigonal planar. Basically, linear means it is just a simple line, and trigonal planar means it is a shape of triangle in a plane. Once we move to sp3, sp3 is tetrahedral, which is non-planar, which is actually a 3D structure. So this is what a planar molecule is. Now, if with this logic we try to find the planarity of this compound, then we can say that this is planar. But actually this is wrong. Why? Because this is not a blanket statement that we can use that always sp and sp2 carbons will have, or compounds will have, planar structure. That is not always true, because over here we just now saw that this sp2 is a trigonal planar. So this this triangle can be in, let's say, in a different plane. Over here the triangle can be in a different plane. sp will be linear, and this particular triangle can be in a different plane as well. So therefore it can be non-planar as well. So it is not a blanket statement that we can use that sp and sp2 hybridized carbons are always planar. But yes, if they are, then they are planar, and the planar molecule has the definition that it lies in a single plane. So with this we have completed the entire solution. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।